Good morning, guys. How's everyone doing? And welcome back to our daily Algebra 2 videos. Today we're going to continue talking about radical functions or square root functions, and we're going to look more into their transformations. So, with that being said, if you can kind of think back, we have this generalized transformation equation that kind of goes to every single kind of parent function we know in existence. Okay, so as it's written, it's f of x is equal to a all times x minus h plus k. Now those are very important things. Those three new new variables we see, a, h, and k. They all have some different thing that does it. Okay, anything that's inside the parentheses or inside the radical for this instance is considered a horizontal translation. So it's left or right movement, and it's always going to be the opposite of what it is. So for what that means is we're going to move h unit right if we have minus h. We're going to move h units left if we have plus h. Okay, so if it's a minus h, we do the opposite, so we go to the right. If it's plus h, we do the opposite, so we go to the left. Okay, pretty self-explanatory in that instance. For the k, okay, it's a vertical translation, so that's up and down. This is going to be exactly how it states. So if it's a plus k, we go up. If it's a minus k, we go down. Okay, and the one that's a little more interesting is the orientation and shape, which comes from a. Okay, so we have three different things we need to look at. The first one, we're going to just take what the value is, and we're going to look at whether it's positive or negative. If it is a negative a, okay, so it could be, let's see, for example, we could have negative square root of x. If whatever that function or whatever that term in front of that square root is negative, okay, it means it's reflected down. So instead of it looking like this, it's going to be reflected to look somewhere down here. Okay, for the next part, we only want our absolute value of a because we've already taken into account the negative, right? We've taken into account of the reflection, so we don't care about that anymore. So we say it's a vertical stretch, so it's being expanded. Okay, it goes up if the absolute value of a is greater than 1. If the vice versa is true, if you have a vertical compression, if the absolute value of a is between 0 and 1. So what vertical compression is, it's going to get closer to this x-axis. If it's greater than it, it's going to stretch, so it's going to expand from the x-axis. Okay. Now, very important. There's a reason I wrote these parent functions in for both of these values. Okay. So once we get a little explanation of what's happening, we can kind of see that. But the parent function has been drawn for both of these equations. Okay. We just have the square root of x, the square root of x, and we have their values. Now, the reason I took these values, if we go back to yesterday, remember, when we worked this out, we only had 4 values that we could graph at a parent function. 0, 1, 4, and 9. Because those are the only ones that had perfect squares. Okay, those are actually what we use every single time when we work these problems out, because we know square root of 2, square root of 3, square root of 5, 6, 7, 8 do not have values. So that has to remain true for every other subsequent function. The only difference is the values of x may change, but what they equal to will not. So whatever's inside this parenthesis will equal 0. So that means when I take the square root of it, it has to be 0. Whenever I work anything out in this square root, it'll equal 1. So it has to be the square root of 1. And you'll kind of see what's going on in that instance right now. So for this function right here, the square root of x plus 1 minus 2. Let's describe the transformations of what's happening. Since I'm working inside the parentheses, right? That is considered to be a horizontal translation, and it shows to be plus h. So instead, if it's plus h, that means I'm going left unit. So we're going to say left 1. Okay, so we're saying left 1. Then right here, okay, we're outside the parentheses now. So this means it's a vertical translation, okay, and it's minus 2. So if it's a minus k, it goes down 2 units. So down 2. So we've described our transformation. Now, if you were just looking at the parent function, you'd be able to graph all these values yourself. So you'd be able to say, okay, I know from 0, I'm left 1, down 2. Let's do it in this color. Left 1, down 2. Left 1, down 2. Left 1, down 2. left 1, down 2. So it should look something like that. Okay? And that would be how the graph would be looked from the translation. Now, to look at it in the standpoint of, let's say I want to graph some values. The values will be corresponding to their appropriate, or I guess whatever or their appropriate coordinate. So a left unit and a right unit are values of x. A down or up unit are values of y. So this means I can rewrite all these in those terms if I apply their proper unit. So if this is my initial value 0, and I know I go left 1 unit, that means I can say this value has to be, then left 1 from 0 is negative 1. Left 1 from 1 is 0. Left 1 from 4 is 3. And left 1 from 9 is 8. Y values will be affected the same exact way, but they'll be affected by the up and down movement. So since I'm down 2, 0 will become negative 2. 1 will become negative 1. 2 will become 0. And 3 will become 1. And if you look, they do correspond exactly to what we just did. 1, negative 2. 0, negative 1. 3, 0. 8, 1. So they'll always correspond back to those parent functions that work, and you can always work it in that standpoint to kind of get your values, okay? And whenever you're not multiplying, you're not changing the orientation or shape, it's probably the easiest way to do it. But sometimes when you are working with those orientation and shape methods, you have to kind of see, you got to kind of use the table method because it makes it a little bit easier, okay? So for number 2, we'll do the same exact thing, but this time we're going to get these down. We're going to use the orientation and the shape to how it affects it. Okay, so we know the first one is just a left and right movement. Okay, so we're going to use this. We're going to describe our transformations. We know we are going, let's go. We're going, since we're minus 2, right? Minus h means we're going right 2, up 3, right? Because we're plus k. And 2 is greater than 1, and it's positive, so it's a vertical stretch of 2. Okay? So it all plays a role in. The only thing that can affect the x value is anything inside the parentheses. In this instance, it's that movement of that right 2 movement. So that's what we're going to do. So all these values right here are going to go move to the right 2. So 0 becomes 2. 1 becomes 3. 4 becomes 6. And 9 becomes 11. Now, everything on the outside of the parentheses has effect. So what's going to happen is we go order of operations. If we were to work this out initially, we would multiply before we add. So all our values here are going to get multiplied by our stretch, and then we'll add our vertical movement. So since this initial value is 0, 0 times 3, 0 times 2 is 0, plus our vertical movement, so plus 3. 1 times 2 is 2, plus 3. 2 times 3 is 6, plus 3. 3 times 2 is 6. Sorry, what did I do there? Sorry. 2 times 2 is 4, plus 3 is 7. 3 times 2 is 6, plus 3 is 9. Okay, so we have our values. So now we can actually graph it. So 1, 2, 1, 2, 3. Actually, I'm going to do this in different colors simply because it looks like I may have put us in a bad spot with this right here. 3, 5. So 3, 2, 3, 4, 5. 6, 7. 1, 2, 3, 4, 5, 6. Here, and 9. So this would be 9, 10, 11, and This one right there, we'll guesstimate it. So it should look something like that. Okay. So as you can tell, all the initial values get multiplied by 2 for the y, and then you have to add that vertical translation. Now this always is just going to go based off of that. So if you're able to apply it, you can. Now another way you can do this is you can just simply plug in these values. Okay, you can make your table, you can do your 9 values or whatever for your 4 points, and you can work it out that way. I prefer it this way, as you can tell, because I always use the same exact points, and I always just apply how they're affected. Okay, so that's it for today, guys. That's our lesson for today. It's a little longer than normal, but this is a little more and need a little longer video. Okay. I hope everyone's having a great day, and peace.